right? And it made it through the loop. Assuming you were going fast enough, it made it through the loop fine, correct?
Yep.
You're okay with that?
Yep.
I want to know what kept the car from falling out of the loop. Is that a reasonable question? All right, so go ahead and check your neighbor on this one. What kept the car from falling out of the loop?
Kinetic energy.
The speed of or the speed that it's going.
What keeps the car from falling out of the loop? You understand my question, right?
Yeah. We discussed it already.
You discussed it?
Yes.
All right, what keeps the car from falling out of the loop?
Momentum.
Momentum. What is momentum?
Inertia.
Inertia is the name we give to the
I don't know.
property of an object in motion
Saying
tends to
like
stay in motion.
Science words. Kinetic energy.
Well, kinetic energy is just a measurement of something. It's not a
I'm just
thing.
I'm
It
just
can't
like
do
saying words that
something.
like I know about this class.
I'm just giving you science words. All I'll do is give you science words.
Well, some of them gotta be right.
What keeps the car from falling out? So speed is an idea, and actually that's okay for me, but which way is the speed? The speed is sideways, right? Even though it's upside down.
Correct.
So why doesn't the car fall out of the loop?
The sideways force is greater than the downward force.
I mean, it has to have enough speed. Here, I'll do a demonstration for you.
I saw this one already.
Okay.
I was watching.
So this is a piece of plexiglass. Okay, can you guys see the plexiglass?
Yeah.
And I put my little Newton's apple on top.
Wow.
Okay? Now, you may have seen something like this before, yes?
It's glued on.
It's totally glued on, right?
Is it?
I mean, sure, like...
Why did that happen?
Oh, no! No, it is not glued on, although it seems like it should be, right? Because even if I need to move this, because people are like, what is he doing right now? Okay? We can go this way.
Science is amazing. If it comes at me, I swear to God.
What's that?
If it comes from me, I swear to God.
So, look at it. Does it look like it's glued on there?
Yeah.
It totally does. Is it, though?
No.
No, I
Go
mean...
off.
So, this is the same question, isn't it? Now, if I go slow enough, so I'll go fast enough, and if I go slow enough,
Oh, I see. Oh no.
will it fall out?
It did, yeah.
Yeah, right? So that's exactly what we were doing before, right? So, here's what I want you to do. I want you to draw, all right? So, we saw this thing happen, and I want you to draw the forces on the apple when it's upside down and moving, okay? So, here's the plexiglass, okay? Here's the apple. So use this dot as the apple and draw all the forces on the apple right now. Okay? Draw the forces on the apple right now. Because we're trying to find out, like, why it doesn't fall out of the loop, right? Is there something pushing it up onto, is there something pushing it up onto the plexiglass? I always want to do it with a whiteboard marker. I've never been able to do it. So that was funny because it fell over and it stayed on for like 2 spins and then it rolled off. And we're gonna try again. Here we go. I'm feeling it this time. No, he's not. I saw a demonstration once, just one time, where a guy took a coat hanger and unbent the coat hanger. And so you still had like the hook part of a coat hanger, and he balanced a penny on it and then did it, and the penny stayed on. I was like, I think the hardest part of that demonstration is balancing the penny on the end of the coat hanger. I don't think my tray is level. What do you think?
I don't think so.
I don't think that worked.
Chicken fell.
See, every year I try, and every year I'm like, nope, not happening. Well, here we go. All right, let me see some forces. Draw the forces!
I did!
Oh, you have to label them.
I'm sorry.
Listen, when you draw forces, you have to label them with the, like, force of Earth on apple. This is called the agent-object notation. Okay?
I was distracted by your marker.
F and then something on something. Okay? Draw the forces. Something on something. Draw some arrows. Draw some arrows. The plexiglass is above it. True?
Should my
So-
thing be flipped?
Which weight is, if the plexiglass is above, which weight can it only push on it?
Down.
Down,
Oh, okay.
right? It's not, because we've established it's not glued on, correct? So at this moment that it's here, if the plexiglass is above it, which way is it pushing? Just down, right? So we can probably get 2 forces out of here, correct?
So we would want 2 going down.
What's that?
Would we want 2 forces going down?
There are, so, Lucas says, I know there's 2 forces going down, right? Now, I don't know their sizes, so I'm just going to do it like this. So what's 1, Lucas?
Force Earth on apple.
Hey. And then force of the,
Plexiglass.
okay. I agree with both of those. All right. What else? Is there more? There's got to be more, right? Or no? So momentum is an idea, but remember, forces have to be exerted by physical objects. You have to be able to name the physical objects that's doing the pushing and pulling. Is momentum a physical object? No, it's an idea. So momentum cannot exert a force. Just like inertia, the natural tendency of an object to stay in motion, can't exert a force because it's not a physical object. Right? Yeah. That's just a vocab word. It's a tendency of an object in motion to stay in motion. So there's got to be more forces, yeah? Or not? Yes.
Yes.
Okay. What else do we have here?
What are the sideways force going right?
Sideways force?
Yeah, going right.
Something this way?
Yeah.
What is it?
Not sure. Person on apple, I guess.
Well, so the person isn't pushing on the apple,
Yeah, but I know what it is, but like,
right?
I know it's just moving.
I'm not touching the apple. The string isn't touching the
I
apple.
know, but I don't know.
You want to go the other way? So it matches the picture? Is that better?
You could play with toys all day.
It's very entertaining, I will tell you.
I think it's their camera.
Is there a force to the right?
Yeah.
What is it?
Speed.
So the plexiglass is only pushing it down. Spinning is not a physical object.
Circle.
String.
The string isn't even touching it. The string is touching the plexiglass.
It's kind of close.
Actually, the air, it's moving this way. The air actually would be pushing it backward, but
Dotted
we don't
line.
need the air.
Dotted line.
So velocity is a measurement of how fast it's moving, but again, not a physical object.
Is this like a trick question here? I don't know.
Well, it's not a trick question. It just turns out
I'm trying to.
there's not a force in that direction.
Oh, that's just rude. You have the velocity arrow going that way.
Yeah, that's because it's moving that way, but there's nothing pushing it that way.
Well,
What's the natural tendency of an object in motion? Stay in motion in that direction, right? You don't need a force for that. That's the natural tendency.
that was a trick question.
It's not a trick question.
Yeah.
More forces.
No.
Star Wars.
The force?
Yeah.
So this is a weird moment because you are all correct. There are no other forces.
Oh God.
Like, think about this as an idea. The only forces on the apple in this moment are down. That's crazy to me. How could the only forces be down? So if the unbalanced forces are in the down direction, what does that tell you about the acceleration? It's also in the down direction, true?
Yeah.
So here's how this ends up working out. I'll tell you it real quick aside. So when I grew up outside of Cleveland, Ohio, between Cleveland and Akron. Those are both near the top, or near northeastern Ohio. And there used to be a SeaWorld there, like SeaWorld, you know, they used to have like
I like SeaWorld.
whales and seals and stuff.
Seahorses.
And there, yeah, when I was a little kid. This is the 70s and 80s.
Whoa.
I know, I'm old. Oh my gosh, you know what this year is?
Your 40th birthday?
No, I'm much older than that. It's my 30th high school reunion.
Oh my gosh.
I graduated from high school 30 years ago this year. That is hella old. I'm unenthusiastic about that. Anyway, so I grew up outside of Cleveland, Ohio, and there was a SeaWorld there. And across the lake, there was this
Everyone
lake.
that came?
From SeaWorld, there was a amusement park, and it had a roller coaster called the Double Loop. And it was literally exactly what you guys built today. It was like a big hill, and it came down and went through one loop, and then it went through the other loop. Now, roller coaster loops aren't circular like that. They have a different shape. It's almost like a teardrop shape, like an upside-down teardrop. It's called a clothoid loop. No one cares about it. Stop talking. But even that riding it, I always wondered, like, why don't you fall out? And people are like, oh, because you have those shoulder straps on it. But you don't need the shoulder straps. They just put it there in case, like, the roller coaster hits a bird or something and slows down. And it's going too slow.
Oh.
Right? But you don't need the straps. Just like, was there anything keeping the car up on the track when you guys ran it?
No.
No, the only forces are the earth pulling the car down and the track pushing the car down. So why doesn't it fall out if only the forces are down? You understand the question? Check with your neighbor, see if your neighbor has an idea. If the forces are down, why doesn't the car fall out of the loop every time?
You're looking at me.
Check your neighbor, yeah.
Yeah.
That's
Everyone,
exactly right.
Your point's opening up on Memorial Day.
Sound like the witch's wheel,
Oh,
where they can strap you in.
yes, that's a great one, right? What a great example. The witch's wheel, you would get in this thing, and the cars would hang down, and it would start spinning around, and the whole thing would tilt up. You weren't strapped in any way, shape, or form, and you were just upside down, no big whoop, right?
Yeah.
What a great example. So why?
You ever had canes?
Why don't you fall out?
You live in Ohio? Mr. Fana, why do you have hot sauce just so you know?
Oh,
It's a trend.
I like spicy food, and Mrs. Panna doesn't, so when I bring leftovers to school the next day, I like to load them up with hot
Oh,
sauce.
okay.
You said Mr. Trento.
I mean, it's not like I'm going to chug it between the left.
I said Mr. Fana.
I said Trento.
I said Fana.
I heard Trento.
Did I misspeak? My bad. I was thinking about how I have to zoom in his class next hour. I volunteered for that.
He's not gonna.
No, he's not gonna be there, but I have to go put my. What?
This is her school. And Mr. Toronto here at school.
No, not today. Just today. It's not like a political statement. It's just like he has to watch his kids.
Yeah.
That was his thing. Yeah.
Possibly.
Yeah.
He
so-
might
All right, what do you
zoom
think?
in, but
Yeah, I'm
Mr. Trento, he might
he's
zoom
zooming
in.
in for our class. I have to like hook up my computer to the monitor and put him going to Zoom.
Tell me what you guys think about this. Nick? Are you dying?
A little.
Listen, there's no dying in physics. You had to die going along. All right, here we go.
Not on the ground.
Tell me, why don't you fall out?
Mom.
I don't know.
You're not going upside down.
Physics.
So part of it is the time, actually. That is very true, right? But consider for a moment, let's look at the object. Which way is he going? He's moving to the right. True?
Yeah.
So because he's moving to the right, if we were to draw a force or a motion map, he would go this direction. But
The apples.
which way is he accelerating? He's accelerating down. So he doesn't move just to the right, he moves to the right and down a little bit. And then now he's going this way and down, and this way and down. And so at every moment, you're an object in motion. Your tendency is to stay in motion in a straight line, but you're being pulled down and pushed down. So you go down a little bit, which is good. What's up? I'm good. Is this the random part of my day?
Sure.
As opposed to the rest of my day, which is completely organized and makes sense to everybody. So what I want you to get out of this today is a better understanding of that, but this idea that the water doesn't fall out of the bucket even though the forces are down.
What? Okay.
I can't believe none of you said